Okay, so all the stuff that you need to write down here about Schoology and whatnot, let me explain to you what that means. I decided that this assignment would be a good one to start by trying to put our answers in Schoology because you have an extended period of time to work on it. There should never be any confusion as to whether or not what you have in front of you or what was given to you as the assignment is supposed to be put into Schoology or not, because like this one doesn't say anything, so it's just a normal assignment that you turn in. This one here says Schoology. That means you're typing stuff into Schoology, okay? So I'm going to give you the piece of paper just like we normally do. You do the homework 100% on the paper, just like you normally do. Then when you're finished, you're going to go into Schoology and you'll put the answers for 1 through 10 and number 13 in. 11 and 12 don't really lend themselves to go into Schoology, so those I'm going to grade just on the paper, but I also look at the paper for all of the rest, okay? So don't think that just because you put it in Schoology right, if you didn't do, this is junk here, you're still not getting any credit for it, okay? I'm going to show you what that looks like here. So when you go into the course, and then you go to the second 6 weeks, it's going, thinking. Then down here, the folder for today says classifying triangles. So in here, there is a blank homework and notes, like there always is. And then there's the classifying triangles with a little green puzzle piece. That's always the test. That's not a test, but that's what they call it, where you're going to enter your answers. So when you click on that, yours does not look like this. You would see this. So it says start new attempt, and it says you've made 0 of 3 attempts. So I usually give you 2. I'm going to give you 3 on this one because it's the first one that you've done. So you'll have 3 attempts just because it's the first one. All right, and when you click start new attempt, then if you notice here, I know you don't have the homework yet, but there's pictures here. There's no pictures here. Putting pictures into Schoology is a pain in the butt, and I will rarely ever do it because it is not worth my time. Plus, you shouldn't be trying to do the homework just from here because it won't make any sense. Most of the time, you won't even see this much stuff. I made these first few like multiple choice because there's only so many things you could put as the answer, and it was just easier than you typing it in. But then when you get to one like number 8, where the question says to solve for x and find the length of each side, there's actually 4 answers that go with number 8. And then, so there are the 4 that you're answering. Here are the blanks. So when you click on blank 2, this is green. I'm not sure how well you can see that, but that means that's the answer that you're filling in, so you know exactly where you are. Okay? Does that make sense? Then you can submit it. When you submit it, if you got any of them wrong, it will tell you which ones you got wrong, and then you can go back and try and fix them before you submit it the next time, but you'll get to submit this 3 times. This is due on the 11th, and that means that in Schoology it has to be done by 7:10 a.m., all right? At 7:10, it's going to cut off, and then if it isn't submitted, it isn't submitted. And then when you come to class, you hand me this paper, and I will also grade this. Okay, we good? Any questions? Yes, sir. You would put where would the space go for an ordered pair? Okay, so when you're typing stuff, do you put a space before your comma? No. So would you put a space before your comma in the Schoology? No. You see how those answers make sense? It's exactly how you would type it. It's not a fancy Schoology way of typing things. It is how you would type. There would only be one space when you do an ordered pair because that is absolutely the only thing that would make any sense. Okay. Why do you need to take a picture of that? Okay, so tell me, where do you find that calendar? In Schoology. See? No. No, a space wouldn't make any sense either. All right. So this is going on page 50 when we are done. A polygon with 3 sides is a what? Triangle. Okay? That's the hard question of the day. Although I used to give a quiz when we get to polygons where you had to name the polygons, so the answers were like pentagon, hexagon, octagon, whatever. But it was always comical because the 3-sided polygon, I would get some crazy answers like tritagon, a trigon, a threegon. It is a triangle. Do not overthink things. Not everything has to be difficult, right? It's a triangle. Okay. Yeah. All right. So, triangle classifications. You can classify triangles two different ways. You can classify them by their side lengths and by their angle measures. So we're going to talk about side lengths first. Although these words should not be new to you, I can tell you that you have not learned the full correct definitions for all of these. For most of them, yes, but not for all of them. All right, so equilateral triangle. So what is that? Anybody? Jacob. Three equal side lengths. Okay, that's the best way to use the word equal that I've heard all day, because everybody keeps trying to tell me they have three equal sides. Can triangles have equal sides? No, but he said equal side lengths, so that's good. Which means that the sides are what? Congruent. Okay, good. So the description, which is really the definition, is a triangle with three congruent sides. So to draw this, it would look like that. All right. How do you say this word? Isosceles. Okay. So what's an isosceles triangle? Anybody? Nick? Okay. Y'all agree with that? Is that your understanding of an isosceles triangle? Okay. So here's the thing, is that may have exactly been what you have been taught. It may have just been what you understood from what you were taught. But I know that that is what most of y'all understand the definition to be, and that is not the correct definition of an isosceles triangle. It is not that you have two side lengths and then the congruent and then the other one is different. So let's draw this and then we'll talk about it. So I'm going to draw it specifically like, oh, that looks really bad. Yeah, it did kind of look like a bad Dorito, didn't it? Okay. Like this. Okay, and I'm drawing it that direction on purpose, because there's a couple of reasons that you come with misconceptions, or a few different reasons. Sometimes it's because you were just flat out taught wrong. Sometimes it's because you were taught incomplete information, and sometimes it's just conclusions that you draw. You don't even realize you're drawing these conclusions, but it's just based on how you've seen things every single time. Because I would bet pretty good money that rarely, if ever, did you see an isosceles triangle drawn like this, because it looks like it's laying down. Would y'all agree with that? You almost always saw it where it's standing up. Does that make sense? Is that true? Okay. All right. Now, is there really a standing up and a laying down? No. But do you know what I'm talking about? Like, I mean, because it's kind of how we think about it. So, because then you kind of think that, well, this is the base because it's always sitting on it, or whatever. I mean, this is the base, but it's not because it's always what it's sitting on. The triangle could be turned any which way. Now, if I was to say this is an isosceles triangle and it has two sides that are congruent and one that is not, that could be a totally true statement. Just like saying parallel lines are two lines that never intersect. That is a true statement. Is that a definition? No, because that leaves it open for other things to happen, right? So what do you think might be missing from two sides congruent? Exactly two sides congruent? What do y'all think about that? That's actually the opposite way of which it needs to go. The correct definition of an isosceles triangle is a triangle with at least two congruent sides. So tell me how that changes what you thought was happening. Yeah, because you can't have one, right? All right. Somebody. Carla, go ahead. Uh-huh. Mm-hmm. Mm-hmm. So is this an isosceles triangle? Yes, it is. And that's important. This is an isosceles triangle. The best name for this is equilateral triangle, but it lives in the isosceles triangle family. It's like a specialized isosceles triangle. Does that make sense to you? And here's why that is so important. Because we're going to talk about properties of isosceles triangles. We're going to talk about properties of equilateral triangles. You don't want to think about them as two completely separate lists of things. You have isosceles triangle properties, And then, since an equilateral triangle is an isosceles triangle, in addition to that, there's a couple more. It's not a whole new set that's totally different rules. Does that make sense? Now, again, I know that the impression that you have been given along the way, possibly even you were told as the definition, you can go into teacher supply stores and find wrong geometry definitions on posters that they want teachers to buy and hang in their room. And that's what's hanging in the rooms of lower level classes, and it drives me bonkers. But that's not the definition. That may be how even some people that had taught you that information understand it, but it's not true. It is at least two congruent sides, because this absolutely positively is an isosceles triangle, even though the best name is equilateral. Does that make sense? Okay? All right, good. Now, scalene. What's a scalene triangle? Okay, great. Okay, good. So it's a triangle, I know what you mean, with no congruent sides. We'll say it that way. It's less words. What you said was fine, but so it might look like this. So no, sometimes the understanding that you have and the definitions that you've learned aren't always so wrong that you have to throw them completely away. You just need to adjust them a little bit to make them correct, so that you understand how things work together. Otherwise, you don't see the connection of things. Okay? So, how is the description of an isosceles triangle different from what you may have heard before? So what's the new part of that? At least. Okay, so at least two congruent sides. All right, so is an equilateral triangle also an isosceles triangle? Yes, that's what we just said. Yes, because it has at least two congruent sides. So, is every equilateral triangle an isosceles triangle? Yes. Is every isosceles triangle an equilateral triangle? No. Exactly. Since it says at least, it doesn't say exactly two or exactly three, but yes. Okay, good. We're all good with that? Yes, so we're just adjusting a little bit of what we have. I think I would just fall over dead if one day somebody came in and was like, yes, I know the correct definitions of all these things we're going to talk about. So, it's, again, I know it's not, it's fine. Well, I'm here to fix things. Okay. So triangle classifications, we're classifying them by angle measures. You can mark out that word lengths. I think I was cutting and pasting, and then I didn't mark off the word because angle measures lengths makes no sense. So angle measures. An acute triangle. Who that hasn't answered something wants to tell me what an acute triangle is? And don't be afraid to speak because you just think I'm going to tell you you're wrong. Because if I'm just going to tell you you're wrong, the chances are pretty good that every single person in here would say the exact same thing. Go ahead. An acute triangle. Wait, what did you say? Say that again. What is less than 90 degrees? One angle? I'm not asking you what an acute angle is. What is an acute triangle? Go ahead. Okay. Good. You're the first person that's put them more than 0 today. Because they keep saying 3 angles that are less than 90, so that means it could be a negative 37. No, but she said less than 90 or greater than 0. What is an angle that is less than 90 and greater than 0? An acute angle. So I can say that what you said is not wrong. I'm just going to shorten the words. Okay. So instead of saying, you can have a negative angle, but just not in a triangle. Right now, anyway. So the description is a triangle with 3 acute angles. So I'm just going to use the word acute instead of saying less than 90 and greater than 0 because it's less writing. So when I draw this, then that by itself isn't enough. So it goes 60 degrees, 70 degrees. If that's 60 and that's 70, what is the other one going to be? Do you have a question? 50. Did you have a question? Are you confused? No, because you said it's an angle that's less than 90. I'm talking about the triangle. You were giving me the definition of an angle. It has 3 angles that are less than 90. Because it sounded to me like you were just saying it's an angle that's less than 90. Is that, because I think that's kind of what you were saying. Okay. So, but this is not an acute angle, it's an acute triangle. So that's what it was. But yes, you also left off the greater than 0, but Okay, we good? Okay, yes. All right, equiangular. What do you think that means? Somebody hasn't said anything. Set off answered. Tuan, what do you think? Okay, so close. Can angles actually be equal? Put your hand down. What? Congruent, thank you. It is a triangle. This translates as equal angles, right? But angles can't actually be equal. So it's a triangle with 3 congruent angles. So each side would be 60 degrees. What? So, oh, each angle being 60 degrees makes sense. I don't know how a side could be 60 degrees. But yes, would each angle be 60 degrees? Yes, because they're all the same. You got to have 180. Good. All right. Somebody else. Obtuse triangle. Another. You can use the word obtuse. Okay. With how many? 1. Can it only have 1? Can it have 3? 2? Can only have 1, right? So I've got to say then with exactly 1, yeah. Obtuse angle. I'm sorry, what? Yeah, sometimes I do. All right. Triangle with exactly 1 obtuse angle. So 120, 40. So what would the other one have to be? 20. All right, right triangle. All right, go ahead, Brandon. What is it? Good. Triangle with exactly 1 right angle. All right. Everybody good with all that? Okay, so I want you to read this next question. I want you to think without speaking. It says, can a triangle be obtuse and equilateral at the same time? And I'm going to get somebody to help me out with that. One. No. I didn't really need to do this. Might be here all day. Tuan, it picked you again. All right. Okay, so Tuan, what do you think? Okay. Okay, you are so on the right track with that. But does equilateral mean congruent angles? What does equilateral mean, Tuan? Okay, I know, because that's your thinking's right, but we're gonna have to adjust that a little bit. That's okay, because we haven't talked about part of this. But see how it says equilateral. This is classification by its sides, and it's asking you questions about angles. So we got to see if we even can relate those things. So let's go back to the front and look at something real quick. All right. So tell me, I'm going to back up to isosceles triangles. Besides the fact that they can have at least 2 congruent sides, tell me something about the angles of an isosceles triangle that you should already know. If I have 2 congruent sides, what do I have? Oh, no. Can't have 2 right angles. Yes, because the base angles of an isosceles triangle are congruent. So if these 2 sides are congruent, then these 2 angles are congruent. And maybe in this isosceles triangle, I only have 2 congruent sides. That is possible. So we take that isosceles triangle property and think about the equilateral. So if I have these 2 sides congruent, then these, oh dang it, I'm waiting on the board again. If these 2 sides are congruent, then that means that these 2 angles are congruent, right? And then if these 2 sides are congruent, that means these 2 angles are congruent. So if the triangle is equilateral, since it's isosceles, it's also equal what? Angular, right? All 3 angles congruent? So if a triangle is equilateral, it's equiangular. You cannot be one and not the other. You have to be both. if you are a triangle. Any other polygon can be one and not the other. So I want you to think without speaking and picture in your head a quadrilateral. I don't know what a quadrilateral is, right? Okay, a quadrilateral that is equiangular but not equilateral. Just picture it, don't say it. A quadrilateral that is equiangular but not equilateral. You got something in your brain? Now picture something, a quadrilateral that is equilateral but not equiangular. Okay. So now tell me, what is a quadrilateral that is equiangular and not equilateral? Wait, quadrilateral, what did I say? Is that what I said? That's what I meant. Yeah, quadrilateral, that's what I meant to say. I wasn't sure that's what came out of my mouth. A quadrilateral that is equiangular and not equilateral. A rectangle, okay? So here's a plain old rectangle, right? It is equiangular. It is not equilateral, right? Now, what is a quadrilateral that is equilateral but not equiangular? Anybody besides Parker? All right, tell me. No, not a square. No, not a parallelogram. What is a quadrilateral that is equilateral but not equiangular? It's not a trapezoid. No, because that has 5 sides. A rhombus. Okay, a rhombus is equilateral but not equiangular. So these are both quadrilaterals. This is equiangular, not equilateral. This is equilateral. This is not equiangular. What is a quadrilateral that is both? A square. Okay. One of the two words, right? Okay, so if you are a pentagon, a hexagon, an octagon, any other polygon, you can be equilateral, not equiangular, and vice versa. But if you are a triangle and you are equilateral, then you are equiangular. So, Tuan, I'm going to help you through this because we just needed to kind of clarify that at the beginning of what you were saying. So you are correct about your no. So let's add what we just talked about, and then I'll let you help me finish it. Equilateral triangles are equiangular. Okay. And so then what were you telling me about it, why it couldn't be an obtuse triangle, Tuan? Well, 3 congruent angles, because we need to get with the angles, right? And with an obtuse triangle, what now? Very good. Okay, so equilateral triangles, left on mess, are equiangular, and obtuse triangles have exactly one obtuse angle. You can't have more than one because then you'll end up with more than 180 degrees, and right now we can't have that. All right, so then it says, can a triangle be acute and equilateral at, that should say the same time, okay? Can a triangle be acute and equilateral at the same time? What do you think? Yes, because if it's equilateral, it's what? Equiangular. And if it's equiangular, what are the angle measures? 60. And are they all acute? Yes. Okay, so we can say yes. Again, it's because equilateral triangles are equiangular with each angle equal to 60 degrees. So all 3 angles are acute. Okay. Everybody okay with that? Yes? Okay, good. All right, so let's go back up here and talk through these triangles a little bit. Actually, let me go back to the very beginning. All right, an equilateral triangle. That is the best name if you get a picture like that. But we know it's also what? Isosceles. What else? equiangular, then it also has to be acute. So that triangle right there, best name is equilateral, but that means it also then has to be isosceles, equiangular, and acute. Does that make sense? Can it be a right triangle? No. Can it be an obtuse triangle? No, because we just talked about that, right? Okay, so let's look at the isosceles triangle. Now, if that's the picture I'm given, the best I can do is isosceles triangle. But can the isosceles triangle be an equilateral triangle? Yes, it can be. Could this be a right triangle? Yeah, it can totally be a right triangle. So it could be a right triangle. Could it be obtuse? Yes, because that doesn't have anything to do with the angles. Because it could be obtuse. If this is 120, then I could have two angles right here, right? So it could be right. It could be obtuse. Could it be acute? Yeah, it could be acute. Could it be equiangular? If it's equiangular, then it's equilateral. Does it still make it isosceles? Yes. Scalene. All right. So a scalene triangle, can it be acute? Can it be obtuse? Could it be right? It can be like a 3, 4, 5 triangle or something. Could it be an equiangular triangle? No, it cannot. Okay. All right. Acute triangle. So can that be an equilateral triangle? Yes. Can it be an isosceles triangle? Yes. Could it be a scalene triangle? Yes. Can it be an equiangular triangle? Yes. Can it be obtuse or right? No. Okay. Equiangular. What else is it for sure? Equilateral, isosceles, and acute. Okay. And if it's equiangular, then it can't be scalene, right? Okay. Obtuse. Can the obtuse triangle be isosceles? Yes, it can. So, because this could be 120, 30, and 30. It'd be fine. Can it be a scalene triangle? Yes, because that's basically what I have right here. Can it be equiangular or equilateral? No. Okay, right triangle. Can it be isosceles? Yes. Can it be scalene? Yes. Can it be equilateral? Because this, right? What's this side called? Hypotenuse. Okay. Is the hypotenuse always the longest side? When you have a triangle, how do you know which one's the hypotenuse? The one across from the right angle. Good. It's not hypotenuse is the longest side. That's not how you identify it unless you have all three side lengths, which we don't have. So I can't say, I know that's the hypotenuse because it's the longest side. How do you know it's the longest side? You can't go by the way it looks. You know it's the hypotenuse because it's across from the right angle. Does that make sense? Okay, good. Any questions about that? Awesome. All right, let's go over here. Classify the triangles by the angle measures. Now, I should have put extra choices on here, and I didn't. But if I asked you to classify by its angle measures, you can't tell me it's scalene because that's not an angle measure classification. Does that make sense to you? It's not even a choice here, but if it was, you wouldn't be picking that. All right, so I want you to look, and I want you to think without speaking. Triangle EHG. I want to know what kind of triangle that is. A right triangle and acute. Can you be right and acute at the same time? What are the three angle measures? Yeah, 30, 60, and 90, so it can't be acute. But it is right. You are the first person that's actually told me it's a right triangle all day long. But yes, it is a right triangle. Yes, really. And here I am thinking I'm spending too much time on the easy stuff. All right. EFH is this one right here. So think without speaking about what we classify that as. Oh my goodness, I'm fixing this today. On. All right. What kind of triangle is EFH? Is what? Okay, I just didn't hear you. Well, I'm sorry. Acute triangle? Okay. So tell me what's the definition of an acute triangle? Obtuse triangle, how do you... Okay. So how do you know you have an obtuse angle? That's okay. You're all right. Uh-huh. Uh-huh. Very good. Thank you. And you're the first person today that's actually come up with the angle measure there, because I heard acute. She was trying to tell me acute, and then she changed her mind. That's fine. But I was told acute today because we got 30 and 30. Well, an acute triangle is a triangle with all three angles that are acute. You don't even have this angle. So you can't come to a conclusion if you don't have all the information. So you got to have this angle before you can even answer that question, and that's what she did. She told me that is 120. So that's how you know it's an obtuse triangle, not because it looks like it. But if you don't actually have that number and know what it is, you don't know how to classify that. Okay, thank you, On. Good job. You did a good job, hon. All right, then FGH, this triangle right here. Oops. Oh. What would that be? Patricia. FGH. Obtuse? Okay, so what are your measures of the triangle? For FGH, what are the angle measures you have? Okay, you tell me. If this is 60 and this is 60, what does this have to be? 60. You can find it a couple of different ways, either using your triangle or the big angle is 90 and that's 30, so that's 60. So how would you classify this? Obtuse? What do you think? Acute? Okay. Is that it? It's equiangular, and just because I know y'all have a hard time saying it, I have a hard time getting words out of my mouth a lot of times too. There's no L here, so you have the most trouble when you're trying to say equiangular. There's no L. It's equiangular, even though it means equal, right? So equiangular. But yes, okay, so it's both. So which one is the best name for it? Equiangular. Okay, good job. Yeah. All right, so now we're going to classify them by side measures. So triangle ABC, which is this one right here. Think without speaking. Here's speaking. Brayden. Triangle ABC, what do you think? You think an equilateral triangle? Why do you think that? Can sides be equal? Okay, how do you know that? Because I only see 15 and 15. So how do you... Oh, okay. Because these are congruent, so if this is 15, this is 15? Yes? And so that makes it what? Equilateral. Okay. And is that it? Brayden. It is also isosceles. Good. What's the best name? Equilateral. Good. Now, we're doing it even though it doesn't say, but we're going to, on your homework it does say choose all names that apply. But even when you choose all names that apply, you need to make sure you understand what the best name still is. Okay. All right, so then we have a BD, this right here. I don't know what that is. Jose, no, he's in 7th. Eduardo. All right, ABD, what do you think? Scalene? Okay, why do you think it's scalene? You really think I'm going to call on you? When's the last time I called on somebody after the thing picked somebody? You just put your hands down. Isosceles, why? Okay, good, because what's this side length? 18. You know why I've made people change their minds all day? Is because all I said was, I didn't tell him he was right, I didn't tell him he was wrong. I said, how do you know? And then once he tried to decide how he knew, that's when he changed his mind, right? And that's when most people change their mind. So when you're doing this stuff, you should always be asking yourself, how do I really know this? And then you might be able to dial in on that. Okay, good job. Thank you. It is isosceles. All right. And then a CD is right here. What would that one be from? Oh my goodness. Nicholas. Scalene. Why? Okay, good. Thank you. Good job. All right, now there's a little side note here. These three numbers don't actually make a triangle. That's a triangle inequality that we'll talk about later. I knew that when I put that on here. I just wanted the numbers to work out a certain way. And I know you probably wouldn't even have caught that, but it bothers me that it's wrong. And so I just want to let you know I know it's wrong. You'll understand why it's wrong later, but just in case you did catch it, I know it's not, doesn't even make a triangle. We're just pretending right now. Sometimes we pretend. All right, so find the side lengths of this triangle. Okay, so this triangle here, what's the best name we can give it? Isosceles. Is it possible that it could be equilateral? Yes. It doesn't look like it, but it's totally possible, right? Is this an obtuse triangle? We don't know, all right? I know you were taught to look at triangles like that and say, oh, that's an obtuse triangle. Those days are over, okay? That's bad. It makes you assume things that are not always true. We really have no idea. We don't even really care right now. Later on, we'll look at how we could even figure that out, but it doesn't even matter. So I need to solve for x so that I can get everything else. Now, anytime you have a diagram that has stuff labeled on it, do you have to use all of it that has x's in it to solve for x? No. Can I add these three up and set them equal to 180? No, because this has absolutely nothing to do with angles, right? I could add them up and set them equal to the perimeter, but do you know what the perimeter is? Nope, neither do I. So I'm not adding them up and set them equal to anything. It is possible that it's equilateral, so could I set these two equal to each other just in case? No, because that's a gamble I don't want to take. I know those are congruent, so I'm going to set those equal to each other. So x plus 3.2 equals 4x minus 1.3. Now, they give me decimals to start with, so can my answer have decimals in the end? Yes. Do I want you to change it to a fraction? No. Okay? So this is going to give me, this would be 3x over here, 4.5 over here. Okay, so you have decimals. Don't go off and do any weird decimal stuff. You can think of it as 45. Just remember to put your decimal back in. You can think of it as money. You got $4.50. You got to split it amongst 3 people evenly. What do you get? 1.5. So x equals 1.5. Right. We good? Okay. And that's x, so that's 1.5. All right. And then I've got to find the rest, so I've got to plug it in. I need JK and KL. Tell me something about those. They're congruent. All right. So are they going to be the same number in the end if I did it right? Yes. Which one's easier to substitute into? LK. KL, sure. So 1.5 plus 3.2, that gives me what? 4.7. So that would be for this one and for this one. Then I do have to plug it into this. So 5 times 1.5 minus 0.2. So okay, so think about this. Isn't 1.5 the same as 1.5? So you want 1 1/2 fives. What's half of 5? 2.5. So you have 1 5, that's 5. And 2.5 more, that gives you 7.5, and you didn't have to actually multiply any decimals at all, minus 0.2. So that gives you 7.3. All right, any questions at all? We good? Awesome.